Good evening. Today we are talking about uh, types of topologies in networking. So you can see that there are bus and ring topology, which is an extended or outdated solution. Currently, the majority networks are in star and extended star topology. Let me brief. The bus topology, which means which are in 2 decades back, there was a solution like pulling the cable, which is a coaxial cable connecting all the computer into it. This has been outdated. The second topology called ring topology, which is even physically it is connected to a central device. From there, logically it works as a ring, which means, so let's say the ring topology is being introduced by IBM company with a central hardware called MAU or MSAU, multi-station access unit. So which means, hope you can see my screen. Let's say you have a central hardware device, which is called MAU. It has a ports and your computers are connected to that ports. 2, 3, and 4. There are 4 computers connected to a central device called MAU introduced by IBM. So here, if a PC1 wants to talk to PC4, the PC1 will bring the communication from here, coming to here, checking in PC to any data to be travel. If not, it will go back again. It will come, then it will go again to the fourth, then again it coming back to the first. So it works like a ring topology. This ring, this considered as a token, a central technology called a token being traveling across the devices like a computers, and the token will look into every computer to know whether any information to be sent and received from each computers. Then it goes to another computer, something like as in a token. Even this technology is also outdated. Now, in current scenario, we have a majority called, this is what you wanted to really understand, the technology called star topology. So let's say you have a computer, you have a telephone, you have camera, you have AP, and so and so. Even you have laptop, you have servers, server, PC, phone, camera, access point, laptop. You have a many edge devices. This will be connecting into a central device with having a many port number. So every device is connecting to a respective port number, something like this. So this central device we call as switch. So all your computers and your edge devices all connecting to your edge devices. So when you have everything is been connecting into one of your central device, then This topology called star topology. Even you can say that you have switch connecting to many devices. But nowadays you can see you have in a multi-floor design. You have ground floor, let's say you have a first floor, few users, you have second floor, few users, and you have ground floor, few users. So basically, the internet coming into either ground floor or even basement floor. So the Orido internet coming to your office or to your building, connecting to your one switch, and you have every floor you have few users connecting to few switch. Like second floor you have three users connected to second floor switch. First floor switch you have few computer connected to it. Same way in ground floor. So when you have multiple floor with the multiple switches, all the switches will be interconnected, something like this. One switch is connected to another switch is connected to the next switch, or in a best practice, the better design state that you have one central switch like internet, you have first floor switch, PC, you have second floor switch with edge devices, you have third floor switch with respective to how many floor that you have, how many edge computer that you have. You need to bring that many switches. Switch is nothing but a central device who will have a capacity to connect your edge devices. Maybe you have IP phone, or maybe you have a AP access points, you have camera, and so on. So you have many products. Your internet connecting to your central product. And from the central product, you connect it to all your next switches, something like this. So you can say that this is your ground floor main switch. We call it as a core switch. The first floor switch, you can call it as a access switch, access switch, access switch. So when you have multiple switch connected to one central switch, then this type of design we usually called as extended star. So in this core switch or the central switch is called as a core switch, and the bottom line where your all edge devices connected, that switch is called access switch. When you have core switch, and you have an access switch, this we call it as a two-tier design. Two-tier in the sense one is core switch, one is access switch. Hope you understand. Any doubt?
Mm.
Okay, let me go back to,
Regarding two tier,
yeah,
core switch plus access switch, it should be one only one access switch, or we can more than one access switch.
it depends upon your
Uh,
design, your requirements.
oh,
Okay,
okay,
so
okay.
let me brief. All the design is based on, depends on the customer requirements. Okay, but generally we have, if you think about in any organization, what you will have, internet. Am I right? Internet coming to your building or your office. That internet is generally connected to Huawei device, which is given by, let's say, Qtel or Orido. Here, to get the internet to your users, the internet should be connected to your device. This device have ports. We will buy 24 ports or 48 ports, or in some time we can buy a 12 ports or even 8 ports. We call it as a switches. If my end users are nearly 30 plus, less than 48, then we can go for 48 port switch. If I have end user connectivity less than 60, which is above 48, then we could purchase 148 and 124. So any switch which will be connecting your edge devices. What are the edge devices? AP, camera, laptop, desktop, access control systems panel, BMS panel, or any kind of edge devices, card reader, anything which you say that an edge devices directly using by the end user will be connecting to one specific switch. Irrespective of model and vendor, this switch is called access switch. So what is access switch? The switch which has a direct connectivity to your edge devices. Then we call it as an access switch. In some cases, you have a very less number, like you have nearly 15 ports only in your customer organization. Then that 15 port switch which can connect your internet directly and your edge devices directly. This case, this switch is acting as a core switch. Core switch is nothing but where you have your direct internet connection or your multi network communication going to be happen. That switch is called core switch. And if the same switch is connecting your edge devices like your PC, laptop, desktop, etc., then even that switch by itself is also acting as an access switch. But in enterprise or medium level of SMB customers, always prefer to go with the two devices. One access switch to connect your edge devices, and the second one is a core switch to connect your internet. So let's say you have access switch. This is your complete building where you have only one floor, ground floor. Okay. In the ground floor, you have a one specific room. Okay. This room, you will have a dedicated rack, physical rack, maybe Norden or Pandiot or any other brand, your rack. Okay. The rack will have U, let's say U48, U47 kind of until U1. In this rack, you will be connecting your patch panel. Patch panel is the termination point for from your field device to your switch. Like example, you have a camera at this let's say in this floor, in this entire building, you have one area called, let's say, um, we call it as maybe office one. Okay, this office one have a camera. This camera connecting to faceplate. From the faceplate, it is coming back to your patch panel, connecting to this. It's not directly connected, it's connected to behind the patch panel. Okay. This connectivity, we call it SCS, structure cabling. And within the rack, you will have Orido router getting an internet connection. Okay. And this rack by itself, you will also have a device called a main switch connecting your internet to your core switch. Okay, so the internet connecting to your core switch. Your PC, let's say here you have a one room, you have phone, you have desktop for one user. Okay, sitting in officer room. So the phone is connecting to your PC, and this phone through the fiber, through the structure cabling, it is coming back to your patch panel. Okay, from the patch panel, you take another patch cord, bringing down, connecting to your access switch. Okay, and your access switch is connecting to your core switch. Your core switch is connecting to your internet device. So a user, let's say a user from the PC, when they type google.com, the service is going from the PC, NIC card, going to telephone. From there, it going to through the structure cabling behind, it coming to the patch panel. From the patch panel, it coming to your access switch port. From the access switch port, it goes to your core switch port. From the core switch port, it goes to your Huawei internet device. From there, it going to the internet. This is the flow. Okay, so the structure cabling is taken care by the passive team. The configuration of the switches is taken care by the active team. So there are two physical department or team in any of your implementation site. Okay, now you have a core switch and you have an access switch within the rack, and you have a single rack in single room in a single building. Then this entirely we call it as, in this room there's a name called DC, data center room, or we can call it as a MDF room. It's a main distribution frame or MDF room. Hope you understand. In the same design, let me know if you have any doubt. The same design, when you have in the entire building, you have first floor, you have a ground floor. In first floor, you have a room, and in the room, you have a rack. Ground floor, you have a room, and in the room, you have a rack.
Hello.
Yep. Yeah, go ahead.
Okay, no issues.
Okay. So let's say the first floor, a user sitting in his room having PC and telephone. Yeah. PC and okay. PC and telephone. So the PC connected to telephone. Telephone connected to your first floor patch panel. And in between patch panel, there is a brush, there is a cable manager, and so on. So for the purpose of the cable arrangements, then finally you have a switch from the patch panel connected to the switch. Okay, this switch is called access switch. In the ground floor, you have internet coming from example QTEL or Vodafone coming to your ISP device. From here, we can even connect it to firewall for filtering. From the firewall, it will connect it to your core switch. Okay. Why do we need a firewall? The firewall inspect your all incoming and outgoing traffic. The firewall, based on our configuration into a firewall, we will be defining what need to be permitted, what need to be blocked. Something like a security guard to inspect any in and out traffic to make sure that all coming traffic are trustworthy. There is no hacker, there is no cracker, or there is no worms, virus, attacker, nothing. Everything is what the exactly the company needed. So that's the role of the firewall to examine. So let's say the internet or the outgoing services are reaching until the core switch, which is belongs to in the ground floor room. Let's say this is rack one. This room we call it as a MDF room or data center room. And all our edge computers, laptop, desktops, camera, whatever, these are connected to my access switch. Now, from the access switch to the core switch, we need a connectivity. This is always connecting through a fiber port. So every switch has copper port and fiber port. So the copper ports is always connecting to your PCs. Like this is copper port, copper. The fiber port generally, the fiber ports are generally connecting between switches. Again, this fiber port from the switch coming back to the fiber patch panel, going through the structure cabling, coming to your same rack fiber patch panel, and from there it coming to your core switch. So in shortly, your firewall connected to your core switch. Hope you can see my screen and you can, I hope I'm audible. The firewall connected to the core switch. The core switch is connected to your access switch. Access switch is connected to your PC. And the firewall has connected to your internet. So the PC going to the outside world, from the PC to the access switch and access switch to the core switch and core switch to the firewall, then firewall to the internet. Okay, so here we could say that 1 and 2, two-tier design. Okay, so when you have two-tier, or we will have a three-tier, four-tier, spine and leaf, ACA technology, ACA centric technology. There are many technologies nowadays available in the market. So all of them are comes under extended star topology. This is what we are begin the topic, extended star topology. So all the extended topologies are, give me a second, please. Yeah, okay, now you can see this extended star topology, where you have a multiple switches connected to your multiple edge devices. The one which we have a mesh topology, we'll discuss later. This is basically within the ISPs, service provider connectivity. Then we have a peer-to-peer and server-based network. This is nothing but when you have a central server, like a Windows. Now we have a 2019, we have 2016 and 2022, a server OS where you can do all your services in your organization, like example, Office 365, DHCP services, or NTP services for the clock, for the time, to synchronize the time. If you have anything centralized and to manage your existing user computers, then we can call it as a server-based network. These are very basics to see what exactly it required to be connected. So now you can see some switches, routers and all. Okay, this is something. Okay, we'll discuss this. It's a purely theory topic. Okay. Any doubt? Okay,
Can
let me.
you go back to ring network?
Yep. Yes.
Okay, one thing I have faced this issue before. Okay, now example, how it will be work means now
Okay, I
example,
understand your
we
question.
can rename PC1, PC2, PC3, PC4, PC5,
Okay,
PC6.
let me conclude this. This ring topology was
Mm-hmm,
outdated 2 decades before. What you are talking about, the ring topology, that you have
mm-hmm.
two separate switches and there is a dicey chain. A connection start from one switch to one PC, then second PC, then third PC, something like this, going back from the last device to the second main switch. Is that the design?
No, 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 no. This is, from that booster switch. Okay.
Yes.
Example, planet switch. Okay. It will be, taking the, this
Okay.
IP and pushing to another. That is mid-span splicing.
Yeah. That's called EPRS
Okay.
technology. There is a separate
Yes,
protocol running.
EPRS. Can you explain about EPRS little?
Yes. Yeah, yeah. Basically, there is every switch has an in and out port, and the configuration for the EPRS stating that the input must be in EPRS configuration domain. They are working with the one domain technology, and within the EPRS, one is acting as a server and the other one it is acting as a client. So always input is sending to the output to the next switch within the EPRS. This is some programming.
Okay. Second, this is bi-direction, right?
Yeah, two-way direction.
How it will be token passing?
No, the token is token. Do not confuse with the token. Token was the old technology 2 decades before. Now
Hmm.
they bought up with the EPRS technology.
APRS. Yeah,
EPRS.
yeah, recently. Okay, okay,
Yeah, yeah.
okay.
Token even
And what is
even
the interface between PyBoard, that FDD, FDDI?
which one?
That is data interface between switches.
Yeah, that is
If you
fiber.
are making dual ring.
Yeah, fiber in and out. Fiber. It could be a single mode. I defined the fiber specific port. Define
Mm-hmm.
or physically mention there is a in and there is an out. If you connect it opposite way, it will not work.
Okay, okay. Here, what is the standard of Sonnet? Sonnet, for telecommunication backbones.
Okay, that we will
You
check
have
and let
any
you know.
idea about Sonnet?
Yeah, I will check and let you know.
Okay, okay, thank
Okay,
you.
okay, fine. I'll send you the link again. You can disconnect and reconnect it again.